In this video, I will explain you electric field created by a dipole on an axial line. Now, this is a dipole, equal negative and positive charge kept at a finite distance of 2a. Now, there are two lines possible. One is axial line. Axial line is nothing but the one which is passing through centers of both the charges. It's an axial line. In the next video, we will see the electric field created by an equatorial line. So that line will be perpendicular to the axial line and will be passing through the centers of the center of the dipole. So this is the center of the dipole. So here anyway, we are going to take this consideration, axial line. Okay, so we don't need this at this moment. Now on an axial line, if you want to get the electric field, at this point we will place plus 1 coulomb here. Now we know the value of electric field is nothing but net force experienced by 1 coulomb placed at that point. So electric field at this point will be net force on plus 1 coulomb. So on 1 coulomb plus Q will be exerting a force in this direction. So I will use a different color. The green color is the force exerted by plus Q on plus 1, that is this one, repulsive force. Now minus Q will be attracting plus 1 in this direction. But what will be the value of these two forces? Comparatively, which one will be higher? See, plus Q is very close to the 1 coulomb. Now minus Q is a distance apart. So here, as this distance is less, as per Coulomb's law, we know that the force will be more. So repulsive force is more here, attractive force is less here. Okay. So if this is the case, what will be the net force here? We know both the forces are at 180 degree apart or exactly opposite to each other. So the net will be higher value minus lower value. That is, here in this case, E due to plus Q minus E due to minus Q. So we have to just, we have considered the direction here. So we only have to put the magnitude here. Okay, so E plus Q. What is the value of E plus Q? We know 1 by 4 pi epsilon 0 Q divided by. Now this position we are going to take from this point, we are going to take from the center of the dipole. So basically the length, either you can take from here or you can take from here. But this is not the standard defined. As per the standard, we will be taking from the center. Okay, so this distance is, say for example, R. Now, if the total distance from center till this position, if it is R, now what will be the distance in between plus Q and this one? That will be R minus A. How come? This one is R, this one is A, so this will be R minus A. 2A means A and A. So this distance is R minus A. And what will be the distance in between minus Q and plus? Then that is R plus A. R plus A. Okay, now we got the distance of 1 coulomb from both the charges. So here I will substitute the distance in between plus Q and 1 coulomb, that is R minus A the whole square minus here 1 by 4 pi epsilon 0 Q divided by minus Q and this one. What is the value? Minus Q and plus 1 coulomb. Distance is R plus A whole square. Now take the common term out, 1 by 4 pi epsilon 0. Q is a common term and all these things are a common term into 1 divided by R minus A the whole square minus 1 by R plus A the whole square. So this will be Q by 4 pi epsilon 0 cross multiply R plus A the whole square minus R minus A the whole square divided by R minus A into R plus A the square of R minus A square into R plus A square. q by 4 pi epsilon 0. This is a plus b the whole square, right? So a square plus b square plus 2ab. Now minus of same here, a minus b whole square, a square plus b square minus 2ab divided by a plus b into a minus b it is. So r square minus a square it will be the whole square. R minus a into r plus a is r square minus a square the whole square. Now open the bracket, q by 4 pi epsilon 0, r square minus r square, these two will cancel. A square and minus of a square, these two will cancel. And 2ar minus of minus, this will be plus, right? So that will be plus 2ar minus of minus plus 2ar is plus 4ar. See, 2ar minus of minus plus 2ar 4ar divided by r square minus a square the whole square. I'm keeping it here. So this can be written as 4 into aq into r. So 4 aq into r divided by 4 pi epsilon 0 r square minus a square the whole square. This is the equation for electric field. Now we will make an approximation here. When the r is very greater than a, so when r is very greater than a, then we can ignore a. So the equation will become E is equal to. So how can we consider this? Let's say we have an HCl molecule. This is a dipole, right? H plus Cl minus. So the distance will be very small and we are finding electric field at this position. So this is very small as compared to this. That's the reason we are taking an approximation like this. So this will be 4aqr divided by 4 pi epsilon 0. A can be taken as 0. So r square the whole power will be r power 4. Now power 4 and r can be cancelled. This will be r power 3. I'm going to rewrite it as 2 into, so 4aq is nothing but 2 into 2aq, right? It is 4aq back. Divided by 4 pi epsilon 0 r cube. Why I have done in this way? Because I can now consider 2aq as dipole moment. Okay, so this will be 2 into, dipole moment is a vector quantity, so dipole moment divided by 4 pi epsilon 0 into r cube. So I can rewrite it as 1 by 4 pi epsilon 0. This is basically constant, we know, right? 9 into 10 power 9 into 2p by r cube. This is a very important relation. See, have you noted one thing here? Direction of electric field and direction of dipole moment is the same. What is the direction of dipole moment? I have told you that it is negative to positive. As per equation, E is also having the same direction. We will check that. See, on 1 coulomb, plus Q is exerting a larger force and minus Q is exerting a smaller force. Why? Plus Q is very close to plus 1 coulomb and minus Q is at higher distance as compared to this. Now this one is greater than this, so net force is in this direction. So this direction is nothing but the same direction, minus Q to plus Q, and this is the same direction. Now here electric field at any point, you can also consider here and do the derivation, you will still be able to get the same equation. So at any point on axial line, electric field will be along the direction of dipole moment, which is from minus Q to plus Q. Okay, thank you.